Welcome to AP Chemistry. This is Unit 1, Lesson 2. Today we're going to be talking about dimensional analysis, temperature, and density. So mostly we're looking at unit conversions. Remember that dimensional analysis is just a fancy term for unit conversions. Typically, they involve more than one step. They may or may not. It depends on what you're converting. So we're going to go ahead and do 3 examples. One will include converting from a metric unit to an English unit or vice versa. One will include converting within the metric system, and one will include converting a unit that is a combined unit. So it has a unit on the top and the bottom, so like grams per milliliter, for instance. In example 1, we're told that a pencil is 7.00 inches long. We want to find the length in centimeters. So just like with any unit conversion problem, we start by writing out our known, our unknown, and our conversion factor. Our known in this case is 7.00 inches. And the unknown, what we're trying to find, is centimeters. So we need a conversion factor that will go from inches to centimeters. So I look in the back of the textbook. There's this page with all of our conversion factors on it. And in the section titled length, I find that 1 inch equals 2.54 centimeters. So I write that as my conversion factor. So now I can do a unit conversion, starting out with the known. Remember that I want to cancel out this unit by putting the similar unit from the conversion factor on the bottom in the next box. And so that would be the 1 inch. That lets us cancel out inches. And then the 2.54 centimeters goes on top. We can go ahead and multiply there. 7 times 2.54. We get 17.78 centimeters. However, we're not done because we need to do sig figs. And so every time we do a unit conversion problem, we want to look at that known and use that as our sig figs. So this known had 1, 2, 3 sig figs, so my answer should have 3. This will round up, so it would be 17.8 centimeters. Okay, so this example will use just metric units. So a Corvette has an engine with a displacement of 6.20 liters. What is this in units of centimeters cubed? So again, we start out by writing our known, our unknown, and our conversion factors. In this case, our known is 6.20 liters. Our unknown is centimeters cubed. Now, we can't go directly from liters to centimeters cubed, but we can go from liters to milliliters, and then from milliliters to centimeters cubed. We know that 1 liter is equal to 1,000 milliliters. We also know that 1 milliliter is equal to 1 centimeter cubed. And we can use those to get us to where we need to be. So we start off with our known, 6.20 liters. Since we want to cancel out liters, we need to use this conversion factor first. We need to put this 1 liter on the bottom in order to cancel that unit out. And the thing that it's equal to always goes above it. Then we look at our other conversion factor. Now we need to cancel out milliliters, so we want this 1 milliliter to go on the bottom and 1 centimeter cubed will go on the top. That lets us cancel out milliliters. And we can do the math. So we would just do 6.20 times 1,000. Gives us 6,200. The unit we had left was centimeters cubed. And then we need to check sig figs. So remember, we look at our known, which had 1, 2, 3 sig figs. And then we look at our answer. Well, the way it's written currently, it only has 2 sig figs because these trailing zeros will not count since there's no decimal place in this number. The only way to get this to have 3 sig figs is to put it in scientific notation, because if we tried to put a decimal point at the end, we would wind up with 1, 2, 3, 4 sig figs, which is not what we want. So we have to change this to scientific notation. So we're going to put 6.2, and then I'm going to keep this one of these zeros to make it have 1, 2, 3 sig figs. And then times 10 to the 3rd power centimeters cubed. And there's our final answer. A Japanese car is advertised as having gas mileage of 15 kilometers per liter. What is this in miles per gallon? Okay, so in this case, we need to convert 2 units. We have kilometers converting to miles, and we have liters converting to gallons. So we start out the same way that we always do. Our known is 15 kilometers over 1 liter. That's what per liter means, is that it's over 1. Our unknown is miles over gallons. That's what we're trying to find. And our conversion factor, well, we're going to need several of them this time. So we need a conversion factor that takes us from kilometers to miles. So I look in the back of the book and I find that 1 kilometer is equal to 0.62137 miles. And I look for liters and gallons, and I find that 1 gallon equals 3.7854 liters. All right, so we can do this in multiple steps, or we can do it all in one. It doesn't really matter. I like to do it in one conversion chart, just for save some space, but you can do this in 2 steps if you want as well. So the first thing I'm going to take care of is changing kilometers to miles. So I look at my first conversion factor. I want to get rid of kilometers, so I put 1 kilometer on the bottom, and I put the 0.62137 miles up top. Cancels out kilometers. And so now I've successfully changed kilometers to miles, which is great. Next, I need to change liters to gallons. The tricky part here is that I want my unit to be on the bottom. So I want gallons to become the bottom unit. So it's a little bit of a reverse from what we normally do in a unit conversion. But it's still the same idea where I'm trying to cancel out the unit. So I want to get rid of liters this time. So my liters are going to be on the top because here they're on the bottom. That cancels out liters and leaves gallons on the bottom. Now I can go ahead and do the calculation in the calculator. And I get 35.282000997. My units are going to be miles per gallon because that's what I had here and here. Lastly, I just need to figure out my sig figs. So I look at my original, had 2 sig figs. I want my answer to have 2. So I'm going to cut it off here. This does not make it round up, so it's just going to be 35 miles per gallon. All right, so with temperature, we typically in chemistry will be using Celsius or Kelvin. In the lab, we will always measure our temperatures in Celsius. However, it's going to be important to be able to convert those temperatures to Kelvin because a lot of the calculations that we need to do, a lot of the equations that we'll be using require us to use Kelvin. We're also going to learn how to convert from Fahrenheit to Celsius or Kelvin or back to Fahrenheit, just as a practice with using that unit and the conversion that's required there. So we're going to do a few examples of that using our different temperature scales. So like I said, we have our 3 temperature scales, Fahrenheit, Celsius, and Kelvin. Fahrenheit is what we use day to day in the US. Celsius is typically used in the lab by most scientists, and Kelvin is often used in calculations. So the difference between Fahrenheit and Celsius is pretty large. They are different size degrees. So 1 degree Celsius is not the same size as 1 degree Fahrenheit. So for instance, if the temperature increases by 1 degree Fahrenheit, it does not increase by 1 degree Celsius. They also start out at different points on their scales, and so they have a different freezing point and boiling point of water or any substance really. So for example, the boiling point of water in Celsius, as we know, is 100 degrees Celsius, but in Fahrenheit, it's 212. For freezing water, it is 0 degrees Celsius and 32 degrees Fahrenheit. So they don't match up, and the size of the degree is also not the same. Celsius and Kelvin are a little bit more related. They have the same degree size. So for example, if the temperature were to increase by 1 degree Celsius, it would also increase by 1 degree Kelvin. The difference here is their 0 point. So Kelvin starts at 0 K. There is nothing below that. That is called absolute zero. We can't have a temperature that is lower than 0 K. So Kelvin is used in a lot of calculations because there's no such thing as a negative Kelvin temperature. And so we can do a lot more in equations and things like that if we don't have to worry about potentially using a negative number. That 0 degrees Kelvin is equal to negative 273.15 degrees Celsius. And so the lowest point on the Kelvin scale is different than the lowest point on the Celsius scale, and they will always be off from each other by this amount. All right, so in this example, we're told that normal body temperature is 98.6 degrees Fahrenheit, and we want to change that to Celsius and Kelvin. So I've written down the 2 equations that we'll need. You can find these in the back of the book. So the first one is to get Celsius from Fahrenheit. We can plug in our Fahrenheit minus 32 times 5 over 9 to get Celsius. And then the second one is to find Kelvin. We'll take our Celsius answer and use that in this equation to find the temperature in Kelvin. So we'll need to convert to Celsius first, since we don't have a direct route from Fahrenheit to Kelvin. So in order to do this, we're just going to plug in that number that we're given in the problem, 98.6. And then we're going to do our subtraction rule for sig figs here. Since 32 has no decimal places, our answer here will have no decimal places inside of these parentheses. Remember, we want to do PEMDAS, so we want to do what's inside of the parentheses first. So I wind up with 66.6. Since I don't want a decimal, I'm going to round that to 67. And then I'm going to multiply that by this constant here. So 67 times 5/9 gives me 37.2 repeating, which I'm going to round to 37 degrees Celsius. Next, I can take my answer from that problem and change it to Kelvin. I do the same thing. I'm just going to plug in, this time, my degrees Celsius, 37 plus 273.15. I'll add those up. Again, my least amount of decimal places is 0. So I come up with the answer 310.15, but I want to get rid of those decimals, so I'm going to put 310. However, I am going to put that decimal place so that I know that this 0 is part of my sig figs. And then I'll put the unit for Kelvin. Okay, liquid nitrogen has a boiling point of 77 Kelvin. What is this temperature in Fahrenheit? So while this question is only asking us to find one other unit of temperature, we will still need to use two equations because we don't have a direct route to go from Kelvin to Fahrenheit. And so we'll need an equation that will go from Kelvin to Celsius, and then we'll need another equation that will go from Celsius to Fahrenheit. So we're going to want to start with the one that has Kelvin in it because that's the unit that we're given. So we plug in our given value for Kelvin, and then we just use algebra to solve for C. So we would wind up with negative 196.15. However, we're doing subtraction here, and so our sig fig rule is the number of decimal places. And since our first number here has no decimal places, our answer will also need to have 0 decimal places. And so I'm going to round that to 196 degrees Celsius. But we're not finished because the question asked us for Fahrenheit. So we need to use this second equation. So in this case, we're going to solve for degrees Fahrenheit by plugging in the answer we just got, negative 196. So in this case, we're going to do negative 196 times 9/5. That's our multiplication and division step. So we wind up with negative 352.8. However, this only has 3 sig figs, so I'm going to round that to 3 sig figs, negative 353 plus 32. And then I can do my addition. Negative 353 plus 32 gives us negative 321. With the addition rule, we're looking at decimal places. Well, both of these have 0 decimal places, so we're good there. And that would be degrees Fahrenheit. And so our final answer is negative 321 degrees Fahrenheit. As we discussed in the last lesson, density is one of our combined units. We have mass and volume coming together to give us density. So density is defined as the mass of a substance per unit volume. And so we can figure out our density using the equation density equals mass over volume. And so we get units of mass over volume, which would be grams over milliliters, grams over centimeters cubed. In weird situations, it might be something like kilograms over meters cubed. It just depends on what we're working with. However, the most common ones that we'll deal with in AP Chem are grams over centimeters cubed and grams over milliliters. A chemist trying to identify an unknown liquid finds that 25.00 centimeters cubed has a mass of 19.625 grams at 20 degrees Celsius. which compound is the unknown liquid. So we're given a chart here of several different liquids that ours could be, and they are given to us in their densities. So what we can do is use the density equation to find out which of these compounds our unknown is. So remember, density equals mass over volume. And so in this problem, we are given the mass and the volume of the unknown. So we plug that in. And we can just divide there to find the density. With sig figs, it would be 0.7850 grams per centimeters cubed. So then we just compare it to our list here, and we see that isopropyl alcohol has the exact same density. And so that would be our answer.